Here is a very important refrigerator problem, so be careful about this problem. I think it will help for getting the value for refrigeration calculation. Thank you. Okay, let's start. The add-on is the refrigerant uses the refrigerant. Working fluid is operates on ideal vapor is a refrigerator cycle between 0.1 and 0.8 and megapascal, and if the reduced vibration is per kg is given, and determine a rate of removal and refrigerator space and power of input and compressor and rejection environment as also COP we have to draw. Okay, we have to find out the COP. So COP we have to draw. Okay, we have to find out the COP. Okay, we know at first we have to know this formula. This actually is not formula, it's the compressor, and then we know this, and this 1, and that one is the 2, that is the 3, that one is the 4. Okay, is the compressor, we know that is the condenser will the heat in out, that means the heat side, and expansion device, and expand the area of an evaporator, that means that will extract the heat. Okay, knowledge is that this side and this which side is heated, more heated side, can you tell? This side is 1, so when we'll this is the lower heater side and equal to mass rate, and S1 is the more heater enthalpy side or more heated side, and minus S4. Okay, for this evaporator side. For working, that means when are considering in compressor work, then which side is more heated side? Which side? Because S2, that means S2 minus S1 is for compression. Okay, and for condenser, this is the heated side, and for condenser, this is the heated side. That means here more heat. This formula we can write in the different two way. Okay, first one is the S mass rate also S2 minus S3. Another way we can write, or we can write here, is that S will be that mass is the Q in, that means compressor work, plus Q lower side L. Okay, this is the basic concept of this formula. Okay, we are going. Yeah, here is the crucial point in this session. Okay, here is a very important, that means, and we know we have to find out the A. We have to find out the A. That means lower side of this question is telling about this A. This A number question is the heat rate removal. That means removal, heat rate is removal from refrigerated space. Refrigerated space, that means this evaporator actually refrigerated space where we put any food, that is, this side is called the evaporator side, that is heat removed. That means any food we put inside the refrigerator is that means evaporator is extract the heat from that space, the power input and compressor. Okay, so here is the lower side also compression work we have to calculate, and we have to calculate total coefficient of work in and QL. Here QL equal to mass rate, as we know, and the S1 minus S4. Here S1, what is the S1? Here also on the side we have to, here this one is the S1. S1 actually we know is the 2, here S1 equal to 239.1 kilojoule per kg. Here S2 set is equal to 275 point this to decide. Yeah, that is the also is given from diagram. So just what I'm giving you, this one is the very is given in diagram, and also S3 is given is 90. S3 is given 95.47 and 47, and all information given. Just we put over this mass rate, you know, 0.05, and all just we put according to that formula 239.16 minus 95.47, and then we'll get that 7.18 kilo answer, the one answer. And we know compression work equal to mass rate equal to S2 minus S1, we know 0.05, and S2 equal to 275, this 0.39 and 239.16. Then after that we get 1.81 kilowatt. And number B, they are wanting this is the rate of heat rejection environment. That means this heat rejection Q, that this Q is we have to find out. Both way we can find out. We can plus both, or anyone we can do. So if we is 1 equal to 17.18 plus 1.81, and then we'll get the 9. And number C, we have to find out the COP. That means COP. Here output is the QL and input is the compression work, and QL equal to is the 7.18 divided by 1.81 is work done. Then we'll get 3.97. That's the unitless number, the answer, because I have performance. Okay, that was the whole calculation. I try to saw this how it's come, and also for this problem figure will provide for this data. So don't worry about this data. If data is will get from so don't worry about this data. If data is will get from figure, that means this figure will provide in question.